Hello everyone, my name is Visalhounuo. In this video, I'll be explaining on nitrate reduction test. Nitrate reduction test is a test that determines the production of an enzyme called nitrate reductase, which results in the reduction of nitrate to nitrite. Anaerobic metabolism requires an electron acceptor other than atmospheric oxygen. Many gram-negative bacteria use nitrate as the final electron acceptor. Bacterial species may be differentiated on the basis of the ability to reduce nitrate to nitrite or nitrogenous gases. Objective of this test is to determine the ability of organisms to produce an enzyme called nitrate reductase, resulting in the reduction of nitrate to nitrite. Or identify the different ways that nitrate can be reduced by bacteria. Principle of the test is all members of the Enterobacteriaceae family reduce nitrate to nitrite, but some members further metabolize nitrite to other compounds. Anaerobic metabolism requires an electron acceptor other than atmospheric oxygen. Many gram-negative bacteria use nitrite as the final acceptor or final electron acceptor. The organism capable of producing the nitrate reductase enzyme converts the nitrate to nitrite. The reduction of nitrate to nitrite is determined by adding sulfonylate acid and alpha-naphthalamine. Nitrites react with an acid solution of sulfonylate acid and alpha-naphthalamine to form a red azo dye. The sulfonylate acid and nitrate react to form diazonium salt. The diazonium salt then couples with the alpha-naphthalamine to produce a red water-soluble azo dye. In each of the test reactions, the appearance of the red dye indicates the presence of nitrite in the test tube, whether as an unreduced primary substrate, a product of the reduction of nitrate by the test organism, or a product of the forced reduction of nitrite with a reducing agent, zinc, for control purposes, indicating a negative test result for nitrate reduction by the organisms. If there is no red color in the medium after you leave added sulfonylate acid and alpha-naphthalamine, means only that nitrite is not present in the medium. There is two explanations if this observation occurs. The nitrate may have been reduced, the strain is nitrate negative, or the nitrate may have been reduced to nitrite, which has then been completely reduced to nitric oxide, nitrous oxide, or nitrogen, which will not react with the reagent that react with nitrite. The strain is nitrate positive. Thus, when nitrite is not detected, it is necessary to test if the organism has reduced nitrate beyond nitrite. This can be done indirectly by adding some amount of zinc powder to the culture. The addition of this zinc reduced the nitrate to nitrite, and the nitrite in the medium formed nitrous oxide, which reacted with sulfonylate acid. The diazotized sulfonylate acid that was thereby produced reacted with alpha-naphthalamine to create the red complex. The development of the red color on addition of zinc indicates that nitrate was not reduced by the organism, which suggests that the test organism is not capable of reducing nitrate. If no color change occurs after the addition of zinc, this indicates that the organism reduced nitrate to one of the other nitrogen compounds and thus is a nitrate reducer. If no color change occurs after the addition of zinc, this indicates that the organism reduced nitrate to one of the other nitrogen compounds. A Durham's tube is placed in the nitrogen broth in order to detect deterioration of the broth before inoculation, as evidenced by gas formation in the tube, and to identify denitrification by organisms that produce gas by alternate pathway. A Durham's tube is placed in the nitrogen broth in order to detect deterioration of the broth before inoculation, as evidenced by gas formation in the tube, and to identify denitrification by organisms that produce gas by alternate pathway. Requirements of the test are the nitrate broth, which contains peptone, meat extract, potassium nitrate, and with a final pH of 7 to plus minus 0.2 at 25 degrees Celsius. The reagents required are alpha naphthalamine and sulfonilic acid. And then you'll be requiring a bacterial suspension, zinc dust, incubator, spirit lamp, and Pasteur pipette. Procedure of the test here is determination of nitrate reduction to nitrite is a two-step process. First, the reduction of nitrate to nitrite is determined by the addition of nitrate reagent, which is sulfonilic acid and alpha-naphthalamine. Then, if necessary, the reduction of nitrate beyond nitrite is determined by the addition of nitrate reagent, which is zinc dust. For the procedure here, first you have to, with the help of a Pasteur pipette, transfer a few drops of the bacterial suspension into the nitrate broth. Then incubate in the incubator at 30 to 37 degrees Celsius for 24 hours. After incubation, look for nitrogen gas first before adding reagents. And then when you see there is no air formation, then you can add the nitrogen test reagents, which is about 6 to 8 drops of sulfonilic acid and 6 to 8 drops of alpha naphthalamine. After the addition of these reagents, you have to observe for color change within minutes or less. If no color change developed, then you can proceed to check whether the nitrogen is being reduced beyond nitrite. For that, you have to add few zinc powder. After the addition of zinc powder, you have to observe for color change. In observation, if no change with addition of alpha naphthalamine and sulfonilic acid, then it is interpreted as nitrite absent. If it turns red with alpha naphthalamine and sulfonilic acid, then nitrate is present, or it will be interpreted as positive nitrate reduction test. If the test gives no color change, then to confirm that whether the nitrate is being reduced to beyond nitrite, to check that zinc dust is added. On addition of zinc dust, if there is no change with the addition of zinc powder, then it is positive, interpreted as positive nitrate reduction test. If it turns red with addition of zinc dust, then it is interpreted as negative nitrate reduction test. Coming to the result interpretation, if it is positive, then there will be development of a cherry red coloration on addition of the reagent, sulfonilic acid and alpha naphthalamine. And then absence of a red color development on addition of zinc powder is also interpreted as positive test. Negative test will be interpreted if there is a development of red color on addition of zinc powder. The uses of this test are: all members of the Enterobacteriaceae family reduce nitrate, but some members further metabolize nitrite to other compounds. It is thus used to differentiate members of the Enterobacteriaceae that produce enzymes nitrate reductase from gram-negative bacteria that do not produce the enzyme nitrate reductase. Then second is the reduction of nitrate may be coupled with anaerobic respiration in some species. And it is also used in differentiating mycobacterium. Also, identifying species of Neisseria and separating them from Moraxilla and Ganglilla. The nitrate reduction test is a critical test for differentiating between Neisseria gonorrhea and Klebsiella denitrificans, particularly when strains of Klebsiella denitrificans appear to be gram-negative diplococci in stain smears, facilitating species identification of Corynebacterium. The limitation of these tests are: the nitrate reduction test may be used as an aid in the identification of bacteria. Additional biochemical testing using pure culture is recommended for complete identification. Second is, due to the possible presence of nitrite in the culture media, a low nitrate medium such as nitrate agar or nitrate broth should be used for the nitrate reduction test. Next is a negative zinc reduction or no color change test in combination with a negative nitrite reaction is presumptive indication that the nitrate was reduced beyond nitrite stage. Although a very common end product of nitrate reduction is nitrogen gas, other end products may be formed. Additional testing may be required to determine the final end product of the reaction. To avoid false nitrite reduction reaction, negative nitrite reaction must be verified by the addition of zinc dust in the medium to the medium. Excess zinc dust has been reported to cause false positive nitrite reduction reactions due to complete reduction of previously unreduced nitrate to ammonium.